This one is for you to try, but let's start it out together. The current on a portion of the Mississippi River is 3 miles per hour. Okay, so that's the river speed. A barge, that's the boat, can go 6 miles upstream in the same amount of time it takes to go 10 miles downstream. Find the speed of the boat in still water. Okay, so already we can tell this is a rate times time equals distance problem. All right, so let's bring out our table. Here we go. Rate times time equals distance. And as much as I hate to say it, life will just be easier if you memorize this table. I hate saying memorize things, especially in math, and I really don't like saying memorize tables, but here we go. Just if you can remember this method and the table, these problems are going to be just much easier for you. Okay, so I think we have enough here. Pause the video, put in all this information, try it out, and we'll compare notes on the other side. Okay, so maybe you did something like this. Said, all right, upstream and downstream. Remember, upstream, the current is pushing back against the boat. This boat is going along upstream, but the current is carrying it back. So the rate for upstream is always boat minus current. That's universally true. Downstream, the current is at the boat's back, pushing it even faster. So the rate for downstream is always boat plus current. Okay, that is universally true. So let's see, what do we have here? We have the current of this river is 3 miles per hour. So we know the current, so we're solving for the boat. So let x be the speed of the boat, which they're calling a barge. That is a big boat. Well, since we know that the boat always comes first, and then the current, we have x minus 3, the current of the Mississippi, and x plus 3. That fills out those boxes. I think we have some distances here. Upstream we're going 6 miles, so 6 miles up, and downstream we're going 10 miles down. Okay, it doesn't say anything else about time, so that's how I know I'm going to use time equals distance over rate. That's just solving this r times t equals d equation for time. All right, so let's plug that in. Distance is 6 over rate, x minus 3. Here we have distance of 10 over x plus 3. And it says the same amount of time. Okay, right here, the same amount of time. Anytime it says same amount of time, that tells you you're setting the two times equal to each other. So I'm going to set these two equal. I'm going to grab this column, bring it down. Let's bring it out to the side here. So we have 6 over x minus 3 equals 10 over x plus 3. That gives us something we can work with. Next, we cross multiply. Bring these denominators up like so. All right, so that gives us 6 times x plus 3 equals 10 times x minus 3. And now we're getting close here. Let's distribute the 6. 6x plus 18 equals 10x minus 30. Okay, let's get all the x's on the right-hand side. So I'm subtracting off 6x. That gives us 4x. I'll add 30 to both sides. 18 plus 30 is 48. Divide both sides by 4 and we get 12 equals x. Okay, what have we solved for? Let's go back. Here we defined our x. Let x be the speed of the barge. And that's what we want, the speed of the boat in still water. That is the speed of the barge. Okay, so the barge is chugging along at a healthy 12 miles per hour in the Mississippi, which is going 3 miles per hour.